angles. When we're looking at this, some of this is going to be repeated what we did in lesson 1. So for the first one, it says find the exact values of the 6 trig functions if the terminal side of theta in standard position contains the given point. So here on problem number 19, I'm given the ordered pair 5, -8. So that means I'm going over 5, down 8. Here's my angle right there. I'm forming a right triangle with my theta right there. All angles are based off the x-axis. So when you're looking at it, I need to find out what my radius is. So again, my 5 squared plus my 8 squared equals my radius squared. And when I simplify it up, my radius is the square root of 89. Using your Pythagorean theorem, you can do the algebra there. So now, my sine of theta is the side opposite, an 8, over the hypotenuse, square root of 89. But again, that's unacceptable when you're looking at this, so you should move the 8 square root of 89. So I'll end up with 8 square root of 89 over 89. Because it's in the 4th quadrant, sine is negative there, so we need to make it a negative. Cosine of theta is going to use the side adjacent over the hypotenuse, which is the square root of 89. Again, at 89, square root can't be the denominator, so I'm going to simplify up. I get 5 square root of 89 over 89. X is positive in the 4th quadrant, so I leave it as a positive answer. Tangent of theta is your side opposite over your side adjacent, because my y value is negative, my tangent is negative. Then I move in and I find the other 3 trig functions. So again, cosecant is the reciprocal of the sine. So I'll have a negative square root of 89 over 8. Secant is the reciprocal of cosine. So I'll have the square root of 89 over 5. And then my cotangent is the reciprocal of my tangent. So a negative 5/8. Now when I look at problem number 22, we have what's called a quadrantal angle. It's quadrantal because it's on the axes. My ordered pairs are -1, 0, which means my radius is also going to be a 1. When I'm looking at a quadrantal angle, the sine of theta is your y over your r. So y is a 0 over 1. My sine is a 0. Cosine of theta is your x over your r, so -1 over 1, which is a -1. Tangent of theta is your y over your x, so I have 0 over -1, or 0. Switching to the other 3 trig functions, cosecant is the reciprocal of sine, so I get 1 over 0, which is undefined. Secant is the reciprocal of cosine, so I get a 1 over -1, which is a -1. And cotangent is the reciprocal of tangent, so I get -1 over 0, which is also undefined. Remember, if you're dealing with a quadrantal angle, there's always 2 undefined trig functions. Questions 26 through 28 and 29 here that we're looking at is asking us to sketch the angle, find the reference angle. Reference angles are always a positive angle. That's going to be anywhere from 0 to 90 degrees. So when I'm looking at problem 26 here, to sketch the angle, 240 degrees puts me into the 3rd quadrant. Again, like last section, make sure you label it. Now when I'm in the 3rd quadrant, to find my reference angle, which is marked by theta prime, I'm going to take my 240, subtract 180, and my reference angle will be 60 degrees. When I'm looking at problem 28 here, a -125 takes me in the clockwise direction. I'm in the 2nd quadrant going counterclockwise. So when I'm looking at it, second quadrant going clockwise, I'm going to take 180 minus the 125. Again, reference angles have to be positive. We don't use the -125, we just use the 125. And when I simplify that up, my reference angle will then be a 55-degree angle. And the last one, that 5 pi over 4, if I I do the conversion to 5 pi over 4, that's the same as 225 degrees. Use that 225 degrees to help you out as to where you're going to go. Starting off, we're going to go in a counterclockwise rotation because we're going positive. When I go into the counterclockwise rotation, and I end up in the third quadrant here. In the third quadrant, I need to take the angle minus 180, so I'm going to take 225 minus the 180, and my reference angle will then become a 45-degree angle. But if I start in radians, I need to end in radians. So you need to convert that 45 degrees to pi over 4. Find the exact value of the trig function means no decimals allowed, simplify fractions, radicals should be in the answer if necessary. First thing you want to do when you're solving them is, if this one's tangent of 300, that means I'm in the fourth quadrant, so I'm going to take 360 minus the 300. So my reference angle that I'm going to use is a 60-degree angle. Drawing out my unit triangle for a 30, 60, 90. Remember your short side is 1, hypotenuse is 2 of your short side, long is your short side times the square root of 3. I want the tangent to the 60-degree angle, tangent to the side opposite, over the side adjacent, but when I'm in the fourth quadrant like I am there, tangent's negative. You can check it by plugging it into your calculator to see if it's going to be positive or negative. Cotangent of a negative 5 pi over 6, if I'm looking at that, the negative 5 pi over 6, converting it by multiplying by, multiply by 180 over pi, I get a negative 150 degrees. So when I'm looking at it, negative 150 degrees, going in a clockwise rotation puts me in the second quadrant. So when I'm in the second quadrant, I have to take 180 minus my 150. I have a 30-degree angle for my reference angle. Using the triangle we just used on problem 35, I want cotangent, but first let's start by finding the tangent of my 30. So the tangent of theta is the side opposite over the side adjacent. Now, because I want cotangent, I have to take the reciprocal. So I'm going to have the square root of 3. And when I'm looking at it, cotangent and tangent are both positive in the third quadrant, so my answer is just the square root of 3. And our last problem shows that we're going to look for the 6 trig functions. We're given one, we need to find the other 5. They're telling us we're in quadrant 2. They're telling us the sine. The sine is opposite over hypotenuse. So again, remember, the angle always goes with the x-axis. So here's my angle that I'm looking for. The side opposite it is the 1. The hypotenuse is the 3. So when I use my Pythagorean theorem, 1 squared plus x squared equals the 3 squared, leg squared plus leg squared equals hypotenuse squared, I'm going to come up with x being the square root of 8. Again, your advanced algebra students, simplifying that up to square root of 2. When I draw it on the picture, I put it as a negative because I've gone to the left as a negative. Now, sine is what they gave us. So remember, they gave us the 1/3. So now if I want the cosine of theta, I need to use the side adjacent, and the negative 2 square root of 2, over the hypotenuse, which is 3. Tangent of theta is the side opposite over the side adjacent. But again, we can't leave that in the square root of 2 in the denominator. So I'm going to multiply both the top and bottom by the square root of 2. I'm going to multiply by the square root of 2, both top and bottom, and the square root of 2 over 4. And don't forget it's negative. Cosecant's the reciprocal of sine. So I get to just flip it, have it 3 over 1, or 3. The secant is the reciprocal of the cosine, so I'm going to have 3 over the negative 2 square root of 2, but again, we can't have that square root of 2 in the denominator, so multiplying both the top and bottom by the square root of 2, I get a 3 square root of 2 all over 4. As I multiply square root of 2 by square root of 2, I get a 2 times the negative 2. Don't forget to take that negative sign with it. And then the cotangent is the reciprocal of the tangent, so I'm going to have a negative